Hi, I'm Alex Persunaru. I'm product manager of Bitdefender, and together with me it's Ionut Leonte, which is our lead software engineer. Today, our presentation will be a little bit more friendly with the normal persons, not necessarily very technical, and we want to give you a look on the perspective of the end user about security. So, going directly into the subject. In current ecosystem, practically most of our homes are full of devices that are connected. But a lot of the consumers don't realize this. Let me give you an example. You have a smart vacuum cleaner. Do you realize that it's a smart device? You have a Kindle. You have an air conditioning that can be programmed remotely. Those are also connected devices. What's the future? Sorry. So practically in 3 years, there were around 1.5 billion consumer devices delivered, shipped towards users. And as you can see, this number of smart devices that will be deployed in consumer homes is increasingly dramatically. So practically in 2025, we are close to 2 billion devices that will be manufactured and shipped towards end users. Now, the bad part. I know that Maslow pyramid is not necessarily something very obvious in a security environment, but this is the reality. Most of those smart devices are targeting the needs of the consumers for shiny, fancy things. When you are looking at a smart TV, you are looking to have a clear image, to have a bigger screen, so the software will work very nicely and look glossy. But, surprise, on top of the most vulnerable devices that we see in our customer networks, guess what? Are exactly those, TVs. You're relying on network attached storage to save your photos, to save your private information. And guess what? Those are the second most targeted devices from home and that are vulnerable. What could be the third? Surprise, that would be the router. Exactly the one device that collects all the traffic from your network. So even if we are talking about a lot of IoT devices, we have a problem that most of them are not focusing on security at all. They are just, okay, create a seamless user journey. And to create that user journey that looks seamless, they cut a lot of corners when it comes to security. Okay, what we've tried to do. We thought how we can protect all the devices from a smart home. As you know, we're a security company. Everybody knows us for Bitdefender endpoints and solutions. But for smart devices, what can you do? Where can you put a solution to protect the whole home? And the answer is pretty straightforward. Go on the router. Okay, we go on the router, but can we fit a security solution into the router? And if we can fit that solution into the router, can we put enough protection technologies there? And yes, we found a solution. The building blocks for these solutions, or the layers on these solutions, are the following. Each time a device is connected to the home network, it's identified. We detect the device. We see what's the device manufacturer, what's the device type, and other specific data. After we detect the device, we do an assessment on that specific device. We scan it for most common vulnerabilities. Does it use has a notification service active? Yes. It uses default passwords, admin, superintendent with superintendent, or 123. Also, we are looking for specific services that are active on that device, and if those services have no vulnerabilities. And after we do identification and assessment, we are starting to protect that device. And we do that for all the devices that are connected to a router. Okay. This was the biggest challenge for us. How many technologies we can cram into a router that shouldn't be a 2,000 euro router with unlimited memory, flash, and CPU. And this is what we put there. First layer is web protection. It's pretty straightforward. You are trying to access a specific website. We check it if it's malicious or not, and if it's malicious, we block it. You have a device in the network that is subject to a brute force attack, or somebody is trying to attack your device to see if that device has that user admin, password admin setup on it. And we block that kind of attacks towards your devices. One of the most interesting features is exploit prevention. So practically, as in most cases, for smart devices that are in the home, the usual user doesn't look constantly, hey, do I have a firmware update? Do I need to change something, a specific setting in on my device? So what happens, how this works, is practically, let's imagine you have an IP camera and has a specific vulnerability. If somebody is trying to exploit that vulnerability on that IP camera, it will be blocked because we detect the pattern of traffic that is trying to make use of that exploit. And even if the camera is not patched and doesn't have the firmware update, firmware up to date, even so, is protected. Another very interesting feature is sensitive data protection. I've seen many scenarios where the users discover with surprise that somebody has used their credit card or their personal data, or they find somewhere on the internet their name with their exact home location. Why? Because some application just sent from their network their GPS coordinates, their credit card details, and private data. What we do, if we detect this pattern of data going outside your home network, we also block it. Denial of service is pretty straightforward, but there's a little bit of twist on this, because if you are talking about denial of service with a telecom operator, they will see denial of service attacks, like attacks coming from outside the network towards their users. We look at denial of service from the other part, from the user part, protecting the telecom providers from their users. So imagine that you have in some homes, some devices that are compromised. They are part of a botnet network, and they are performing attacks somewhere. What happened with the traffic inside the foreign operator network is getting clogged with this traffic generated by multiple devices performing a denial of service attack. I know it sounds a little bit far-fetched, but we did a test with one of our customers in the United States. And for a period of a week, for a specific network segment, we saw that our solution cleaned up around 20% of the traffic. So practically, from that specific segment of the network, we free 20% of the operator's bandwidth, just cleaning up this kind of junk traffic. And of course, one of the last here on the slide, but not the last from what we can do on the router, is anomaly detection. So practically, this is the last layer of protection if any of the previous one fail. What it does, practically imagine that you have a fridge, a smart fridge that automatically connects to Amazon and orders your favorite beer. And suddenly the fridge is connecting to another web store from eventually North Korea and is starting to order something else. Then the algorithm will detect that your fridge is behaving in an anomalous way, will block that traffic, and will notify the user, hey, you have a problem with your fridge. It's changing his preferences towards the beer. The good part with all these technologies is that what we saw that other competitors do, their solution is they detect a device that is compromised and they block the device. Our approach is a little bit different. We clean up the traffic, but the legitimate traffic made by that device is allowed. So practically, for a net user, that device works in a normal way. Of course, it will be notified that the device has a problem. Okay. Now I will let Ionut to tell you about the dark side of the approach.
Testing? Okay. So Alex focused on the why, right? Users need security that just happens. You can't trust the user to behave in a secure manner, right? Which is why the Hello? Okay. Which is why the router makes perfect sense to have something like this. So now I want to talk for a bit about how you actually make something like this work. So the situation right now is pretty dire from the perspective of a third-party application developer. In order to get any kind of application on one of these devices, you have to start at the root of the problem, which is that currently the entire industry is very focused on a model where the chipset manufacturer controls a lot of what happens, because all of these devices are running extremely extremely heavily patched versions of Linux. They have heavily modified Linux distributions running on them, right? So it's extremely difficult to get anything outside of what they provide when you go and buy chips from them, right? So for us, for example, we currently run on over 80 router models, and a lot of those required a lot of manual work to make happen. We have to collaborate with ODMs. We have to collaborate with the hardware, with the actual vendors of these routers to get our application there, which is an extremely cumbersome process. Firmware is usually seen as a very monolithic kind of entity, right? In order to get any kind of new functionality on a router, you usually have to completely change the firmware, right? There's no. If you think about these devices and how similar they are to your phone, right? They run very similar kinds of processors. they have very similar kind of connectivity, and yet the main difference is that we think of phones as generic computing devices, and we think of routers as appliances, right? And the reason for that is that you can install applications on phones, right? You as the user control what your device can do, right? This doesn't happen on routers. And again, this is because of the current development model that is pushed from the very bottom, which is the chip manufacturers, right? So what we are seeing is a shift where both consumer router manufacturers and ISPs are pushing to move routers closer to what a generic computing device is, right? Essentially, they want to run platforms, right? They've seen that platforms work. They've seen that they generate a lot of revenue, and they want in on that. So they want applications on routers, right? This is slowly happening, but it is happening, and it's coming soonish. So one way they are doing it is through integration of container management solutions, things like Docker or LXC. This is still using the existing paradigm where they just take the firmware as it is today and just retrofit these containerized solutions on top of them. And the kind of applications they want are obviously cybersecurity, but there's also physical security, right? We have Wi-Fi sensing. We have Matter, which is quickly becoming a thing, and that will allow the router to act as your main IoT hub. A few others there, but yeah. So the point I'm trying to make is that the router is moving toward a more generic computing device rather than just an appliance, right? So again, today, this is still basically retrofitted on top of the existing firmwares, but we are seeing things like RDKB, which has been around for a while, but most importantly, Purple OS in the service provider space, which is an effort mostly by service provider, by ISPs, to also standardize the full software stack. So both the OS, but most importantly, the application management layer. So what I'm trying to say, I guess, is that change is coming for the router. This is obviously going to open interesting possibilities for both legitimate users and less legitimate users of these things. So interesting times are coming. Thank you.
Okay, I guess that leaves us ample time for questions. So, okay, I'll give you my mic. We'll start over here.
Thank you for the interesting presentation. So one question is, are you also collaborating with OpenWRT or DDWRT as an OS provider for routers?
Not directly, but OpenWRT is involved in Purple, right? Purple OS is at least, it started as being a fork of OpenWRT, right? So there are OpenWRT people involved in Purple. So we don't collaborate with them directly, but through the Purple project, we do, essentially.
Okay, on to the next question. Okay.
Hello, thank you for presentation. I would like to ask, you presented before that it's applying a pattern to identify the attacks. Yeah. So, is it only from external attacks, or also it could identify from in-house attack? For example, rogue phone from local network. You know, or some unusual application from mobile that is running on the personal phone. Thank you.
So at the router level, we try to only focus on IoTs because they have predictive traffic patterns, right? So for those, we detect both anomalous traffic patterns that are generated by the device itself, and also if it's exposed to the internet, the other way around, right? For your phone, your tablet, we still expect you to need a local agent, right? Because they have unpredictable traffic patterns, essentially, right? We do have anomaly detection for IoT. That's the main focus there.
Okay, who else? Okay, I'll go here and I'll come back to you, promise.
Hey, quick question regarding the anomaly. Does it detect any backdoors that may come baked in the firmware of the IoT devices?
Can you please repeat the question?
The anomaly part detection, does it detect backdoors that may come baked in the firmware of the IoT devices?
It depends. So practically, you describe a scenario when a user is updating a device with firmware that is compromised, right?
Yes, or it may come with the compromised firmware from the factory, because most of the IoT things come from China, for example.
Can you?
Yes, the firmware may come baked in the product from the factory, because most of the IoT devices come from China, for example.
It all depends on how the device will behave after the firmware is installed. If the device is starting to request connectivity to some command and control servers, we will detect that and we will block it.
Okay.
Also, there's another layer, which is the vulnerability assessment, right? So when a device connects to the network, we try to scan it, right? So if there's like any open ports or stuff like that, we should be able to detect it like that as well. So the traffic, the behavior is based on the traffic, but we also do some checks on the device whenever it comes online, right?
Okay, coming.
Hello. Shouldn't the focus also be towards user protection and user prevention, including Internet of Things inside the house? Because I'm sure most users won't change the default password or one will leave their devices strictly open. I mean, considering the fact that you will help the router, let's say, are you also uh, helping the user to not make the simplest of mistakes? I mean,
So practically when we do the vulnerability assessment, if we find a device that has a vulnerability, we also notify the user about that device vulnerability. And the user has the option and should take some corrective actions like changing the password or updating the firmware, or depends on what vulnerability we detect there.
So it's still the user that has to do all these things. You're not the one.
The user, as a best practice, yes, the user should do that. But if the user does not update his firmware or doesn't change his password, and somebody is trying to brute force that password, we will protect him.
Okay, so
there's also the fact that we try to focus on the admin for these notifications, right? So if you are the admin in your home and somebody else in your family accesses it, you will still be the one who gets the notification, right? So we do rely on there being some higher knowledge user that is actually managing the security, right?
Okay, so not all the users, but the admin. Yeah. Okay, thank you.
Okay. Okay. Last question.
I'll be very brief. For the example you gave with the extra junk traffic that you filter out, what was the junk traffic? Did you check it, maybe decrypt it if it was encrypted? Did you find the source or just filter it?
The batch of the network was pretty large to make a deep analysis. It was a lot of malware. It was a combined also with DDoS. So what we suspected, it's one or two users from that part of the networks were the main generators of junk. But in usual conditions, let's say 20% is pretty high, but in usual conditions it's around 10, 15. It all depends on, it's not a simple answer. Depends on the profile of users in that network segment, age, behavior, density. There are a lot of factors.